So these house prices are also near the ocean, so the prices are higher. But houses far from the ocean, as we go into the land, the prices are decreased. Okay, so the houses, let me make it bigger. Houses in, for example, Los Angeles. Hello guys, my name is Arash. Welcome to my YouTube channel, Data to Deploy. In this video, we want to talk about Pandas data frame visualization. So in the previous video, I talked about 12 Pandas tricks data scientists can use to make their workflow faster. If you haven't watched it, click on the top of the screen at the right side, or you can also read the blog about it. I also put this blog link in the description. You can go and read it. Also, I put the GitHub repository there. But in this video, we want to talk about visualization part of data frame. Okay, we want to see, for example, how we can visualize the features and rows and features of our data frame with plots. We have different type of plots, for example, line chart, bar chart, box plot. In this video, we want to run the code together and learn more about this. Also, I put the GitHub repository for this project in the description. You can simply copy paste all these codes in your Google Colab and see the output yourself. For this project, we are going to use California housing pricing. You can find this dataset in Kaggle.com website or in the GitHub repository. I put both link in the description, and also the links are in the notebook. If you go and check GitHub repository, you can also find these two URL for downloading data frame. For example, here in Kaggle, you can read about the dataset. It's about year 1919 California houses. Here, for example, you can see about each column, each feature, what it means, what value it gives to us, and also all our data frame rows and columns here. So for example, here you can just download this CSV file. For example, here you can click on download, download it as a zip and then extract it, or with this code you can download it. But I use the GitHub version, so I will show you how you can read your data frame later. It's, for example, Pandas as PD, Seaborn as SNS, and Matplotlib .pyplot as PLT. So we run this code, we got the marked, so our libraries have been imported. We don't need to install anything on Google Colab. Then here, if we use %matplotlib inline, later when we want to generate our charts, we don't need to, here for example, as you can see, we don't need to write plt.show anymore. If we add this at the beginning of our code, later we don't need to write plt.show. Okay, so it's based upon you what you want to do. Then here, this is the part where we can download our data. So we are using this link, which is our housing.csv file from GitHub repository, and then we read it by writing pd.readcsv, and inside parentheses our URL, the variable we get to our GitHub repository link. Okay, so for example, because we are using .csv here, we write here read.csv. If for example it was maybe Excel or JSON, we can simply write read dot for example JSON or read dot Excel. Then we run this command. Now our data have been gathered and downloaded, and we named it, give it a variable df. Now here we can check our data frame shape, our data frame data types, and see the first few rows of our data frame. By running print df.shape, we can see our data frame shape. It has 20,640 rows and 10 columns. If we run df.types, here as you can see, these are our columns, our features, and their data type. As you can see, 9 out of 10 of our features are numeric and are float 64, and one of our feature, ocean proximity, is object, which means a categorical variable, but all of them others of that are numerical. Then with df.head we can see the first 5 rows of our data frame. Here as you can see, for example, we print the first 5 rows, and these are our feature, 10 feature we have, and these are our dataset rows. When you read the data frames with Python and with Pandas, the first row start with 0 index. Okay, so this is the first row, but the index is 0. And here as you can see, these are our feature, for example, longitude, latitude, house median age, total number of rooms, total number of bedrooms, the population, household, or median incomes, median house value, and the distance to ocean. So for example, because this data set is for housing prices in California, so California has access to ocean. So here we can see, for example, how many of our rows, how many of houses are near ocean or have a distance to ocean. Later we will see these two. Then after this we can this is very important, we can check how many null values we have in our data frame. Okay, so for example, this data set is very large. It has 20,000 rows of data. Okay, so it should have missing values. For example, imagine, for example, the total rooms may be missed for few houses, or the median income may be missed. For example, when they try to gather data, someone may refuse to write their income, so we may have missed values here. How we can see? By writing df dot is null. If we run df dot is null, we get a boolean data frame, which false means there is value, and true means there is no value. So it's hard to see the number of total missed value. We can just add dot sum, and here as you can see, just total bedrooms have 207 rows of missing value. Okay, so total bedrooms out of 20,640 rows of data, 207 of them has missing value, or NaN or a NaN value. Okay, after that we can go and start plotting our data frame. So we can plot all our feature or we can plot, for example, one feature or one feature against another. So for example, here first we want to plot a histogram to check the target variable distribution. For example, we want to see our median house value, which is a continuous value. We want to see the distribution of this data by using df.plot and inside the parentheses the kind equal to hist. For example, here as you can see, we call this feature in our data frame df bracket, and inside the quotation the feature name dot plot, and inside our plot we choose hist for our kind, beans, which I will show you later what is it, the fig size, which is our figure or the image size, we can change it. This is the x and y array. We can, for example, make our image bigger or smaller. The color of our histogram, if I run it here, as you can see, for example, when bin means we divide our data in by 50, so this each bin is showing 50. Okay, 50, 50, 50. And for example, the fixed size is 14 and 6. If I change it to 10 and 6, you can see our image size reduce. For example, I can change this to 3. Now you can see very smaller. And for example, the color still blue is the color of our histograms. We can, for example, change it to green. Here, as you can see, for example, it turned to green. And if I change the edge color to white, edge color refers to the lines between histograms. So for example, here we change the histogram color and the edge color. And also we can add title to our plot. For example, distribution of median house values in California. And also we can add X label, this text, and Y label to our plot. Okay, so for example, here we want to see the distribution of median house value. As you can see, it has a right skewed but with one big outlier, and the X array is for median house value in dollar, but Y array is the value counts of each bin. Okay, we named it frequency. And plt.title layout will automatically adjust subplot parameters so the subplot fits into the figure area. And plt.show, because in Google Colab we run each capsule separately. For example, when we run plt.x label, plt.y label, it's just used for this specific capsule. Okay, so the next capsule we want to run doesn't use this. Okay, will not use this. We should write new X label and Y label for the next figure. After this, we going to the next part, printing all numeric columns at once. So previously I told to you we have 9 numeric column and 1 categorical column. So here we want to plot all numeric column at once. With df.hist histogram, we can simply plot all numeric columns. For example, we can add the bins. For example, also here, for example, bins is 50 here, we can change it to 100. Or for example, we can change it to 10. Okay, so if we change bins to 10, the number of histograms decrease because we have just 10 bins. But if I change it to, for example, 50, the number of histograms turn to 50. Here is the same. For example, we use bins 30 and the figure size 15 and 10. The color is still blue, edge color white. We also added plt.subtitle. The difference between subtitle and the title here is that because here we are generating multiple plots, so subtitle means the main title for all of these charts, okay? And for example here y equal to 1.02 means the distance between this subtitle and the plots, okay? If I add it, for example 1.5, the distance between the subtitle, and here you can see the distance between subtitle and our plots. So 1.02 is good. And also font size is equal to 14. We can increase it, for example, to 19, and the subtitle font size will increase. And plt.title layout and plt.show. And here, as you can see, our numerical columns have been printed. For example, this is the longitude, this is latitude, this is housing median, this is total room. So you can see, for example, the most are around here with right skew, or for example total bedrooms, population, median house value, which we printed later previously, or median income. You can see that our median income is very near normal distribution, but a little right skews. Okay, so for example, there are a few people with median income higher than, for example, 6 to 8. Okay, and our median income in this data set have been scaled between 0.5 to 15. Okay, so for example 6 means $120,000. Okay, we scale it and decrease it into between 0.5 to 15, and these values you can see we printed. Next step is to sorting our values and then plotting them. So for continuous values, like for example median house value, median income, population, okay, this is very good. Or imagine, for example, stock prices or age. These are continuous value. First, we sort our values, and by default sort value sort data in ascending format. Okay, so here we are telling that these two features of our data frame, median income and median house value, sort this value based on median income. So if you let me run this, and after that I can simply write print sorted df. Let me df sorted. If you print it here, as you can see, the data set sorted based on median income. So first we are seeing the lowest income all the way to highest, and these are scaled numbers. So in reality, for example, it should, for example, 15 should equal to $300,000 per year, and 0.5 should be, for example, $50,000 per year. Okay, but the data set scale to these numbers. If we decrease alpha, the image color decrease, and if we increase it, for example, to 1, it's get very more transparent color. And we named our give the title to our image, and X label, Y label, and plt.title layout and plt.show. And here, as you can see, because we have 20,000 rows of data, so line chart is not very good for seeing the relationship between median income and median house value. Later I will show you what type of plot is good for such a comparison. And next thing we can check is for example we can bin our income feature and plot the mean of it to see the trend. For example, this is another way we can see the relationship between median house and median income. Here, for example, we cut our median income into 20 bins, and then we group by our income bin and median value house and get the mean. Then we plot it. Here, as you can see, for example, in here, for example, in this bin, the median house value is here, and for the next bin, the median house value increases. Okay, so somehow it's telling us that when the median income increases, the median house value will be increased. Okay, it's reasonable. So someone who has more income has a more house value. Okay, this chart is clearly show us this. Next plot is bar plot. Okay, we can simply by writing df.plot.kind in the parentheses kind equal to bar, we can compare numeric values, numeric columns features with our categories feature. Okay, so for example here you see df.group by and our category feature ocean proximity and by total number, and the mean of this, if you don't know what mean means, dot mean is equal to, for example, we have 5 number 10, 15, 20, 25, 30. Okay, so when we are saying mean is equal to 10 plus 15 plus 20 plus 25 plus 30 divided by 5, which equals to 25, 50, 100 divided by 5, which equals to 20. Okay, so the mean here is 20. And when we are saying mean, it's computes such thing for our data frame. For example, here for our total rooms feature, then we sort value and plot it. The kind is bar. For example, the color is coral, which is very near to orange. Edge color are white, fixed size, title, and we give it X label, Y label, and for example here with xticks, plt.xticks, we can give degree to our each column name. Okay, for example here it's 45 degree rotation, so it's rotate instead of these names right in one line, in a horizontal line, it rotate 45 degree. So here, for example, as you can see, we have 5 different distinction in our categorical feature. So the ocean proximity, one is island, which means the houses are in island. One is near bay, one is near ocean, one is closer than 1 hour to ocean, and one is inland, completely in the land. Okay, so for example here we can also see the value counts for our categorical feature. Here, as you can see, for example, island, the number of island houses are just 5. Okay, compare it to, for example, less than 1 hour to ocean, which are 9,136. Okay, so simply out of 264 rows of data, 5 of them are for rows are for island houses. Then 9,136 rows are for less than 1 hour to ocean houses. Okay, so and here you can see that islands are just 5, but these 5 have a total rooms of average total rooms of around 1,500 compared to other distances. So here you can see that the island is standing out, very small sample size but extreme values. Next, here we can group by our data frame, our ocean proximity, our categorical variable with median house value, get the mean and sort value, and then plot it. But here we are plotting our data frame in horizontal format. Okay, this is vertical and this is horizontal format. By just simply change bar to bar h, which equals to which means bar horizontal. Okay, so here as you can see, and this way our bars are more clear, they can be longer and easier to read the values. Okay, but here also we can increase the fixed size, for example here to 12. Here as you can see our plots got bigger, but it's easier to generate and print the horizontal form. Next thing is correlation heat map. By simply writing df.correlation, which shows a linear relationship between every numeric feature in our data frame in a single view. Okay, and for getting the correlation we can just do it with numerical values, so we need to cut categorical features from our data frame, so we can print correlation with numerical values. Simply we can say df select d types include float 64 and int 64. Previously we checked our data frame types, all our numeric values are float 64. Okay, so here for example we choose our, we can also delete this part, we choose our numeric columns and named it df numeric, and then simply df numeric dot correlation, and we put this value in correlation matrix variable, then simply plt.figure and choosing our fixed size, then with sns.heatmap and giving our variable correlation heatmap, we can generate such a image, such a plot, which gives us a very important information from our dataset. And here are a few settings you can add to our heat map. For example, anode, which show the correlation value in each cell. If turn it to false, no value appear on your correlation, but with true you can also see the values. And for example we change the maximum and minimum number to between -1 to 1, so you can see that all values are near zero, near -1 or near 1, so it's easier to understand our data. I talk about this. And for example with FMT we can say that just 2 decimal point to show just 2 decimal point. Here, as you can see, we can just see 2 decimal point. For example, if I turn it to 4, we will see 4 decimal point. And we give it a CMap, color map, for example, cool warm, line width, and a square to true. For example, right now it's a square. If we change it to false, and based on our number of features, here as you can see, for example, it's turned to rectangle. So true, we get a square box. And we plot and add a title. And here as we can see, for example, we can see our total rooms feature has a correlation with household near 1. Okay, this means that these two features are very correlated. Okay, so it means that future for machine learning models, these two features are giving the same prediction power to our model. Okay, so for example here, total rooms and total rooms are 1, which means that these two are 1 equal. These two are the 1 feature, and so you can't, for example, use these two as a 2 separate feature in your data set. Same here, for example, for household with 0.9. This means that these two features are very correlated, and you can delete 1 and use just 1 for your machine learning model learning and prediction. For example, here also you can see that median income and median household has 0.68 value. This is also telling us that, for example, when the median income increases, the median household value will increases too. And here we can, for that part, we try to see the median house value compared to median income. I told you there is a better way when our data frame is very large, for example 20,000 line of rows. We can use a scatter plot. Here as you can see that it's way better, and we can understand our correlation, our relationship between our two features better. So here as you can see that we have a decent correlation between median income and median house value. Okay, it's not complete correlation, but we can see that as median income increase, the median household value will increase too. And these two lines around $500,000 and $350,000, these two lines are especially inside with $500,000, is telling us that these values are a kind of outlier. We can see that most of our data frames are here, and as the median house value increases, or as our median income increases, our data points are decreased. But this time is telling us that this is the outlier. Okay, we can see the outlier for here with a scatter plot. Next plot is geographic dimension. This also is very cool plot. Here as you can see, with plot kind scatter, x is longitude and y is latitude. And for example here, for example for our CMap, we give it a name, our map color, our color bar equals to true. And here as you can see, for example, this is kind of similar to California map. If you search California, here as you can see that this map is very similar to this. Okay, here with scatter plot and the data set we had, we are seeing how the median house value are across different region. So for example here, when the color goes to yellow, it means that the house prices are higher. So these house prices are also near the ocean, so the prices are higher. But houses far from the ocean, as we go into the land, the prices are decreased. Okay, so the houses, let me make it bigger. Houses in, for example, Los Angeles or here Santa Cruz are uh, expensive, but when you go near to the land and mountain, the prices decrease. Okay, for example here with this plot we can see this, where here is California and here I guess it's Santa Cruz. Oh yes, that's it. Or for example San Francisco. Next plot is pair plot with Seaborn. Pairplot generates a matrix of scatter plots for every combination of features we're trying to select. Okay, with pairplot also we can spot and find correlated pairs and non-linear relationship. So for example here we just want to uh, pay plot for these four feature: median income, median house value, total rooms, and housing median age. And because our data frame is too big with 20,000 rows, we by simply dot sample we use just 2,000 rows. Then with sns.payplot and the first value giving our data frame, and for example here we can see that we can telling that this these four chart, which are these charts here you can see are telling the same feature. This is, for example, the Y array is median income and X array is also median income. So we are saying that it's histogram. We can also, for example, change it to what's that? I forgot it. For example, to KDE. Okay, if we plot this, you can also see a KDE chart too. And also these are some settings, for example, the line length, the color, and we added a subtitle to our pair. Here, as you can see, for example, here again the median house value compared to median income, we are seeing a quite good correlation. Or also, for example, total rooms and median income. So as the median income increases, the total rooms increases also. But the median income has no correlation with housing median age. So the age of house has no relationship with relationship to median income. Okay, next we are trying to plot box plot. Okay, with box plot we can show median, interquartile range, and outliers in one image, one plot, with simply df.boxplot. And inside it, for example, we are saying which column we want to get data. For example, median house value by for example our categorical feature ocean proximity. We give it fixed size, and for example the details we want, for example the color of the median and line width, and give it title, or if you want you can give it subtitle, X label, Y label, And here, as you can see, for example, here it's very similar to stock charts, candlestick. Okay, this is the lowest value, this is the highest value. These circles are our outlier, and in this box are our interquartile range. I have written a blog about this statistics. I put the link in the description. You can also go and read about it. And this red line is the median. So the median house value, which are in approximately 1 hour to ocean, are around $200,000, a little higher, $220,000. Okay, so as you can see that the median house value, the mean house value in island are much higher than houses inland or near the ocean. The last chart is Plotly. Plotly is very good for interactive charts. You can see that here completely the difference between Plotly and using Seaborn, Matplotlib, or Pandas plot. Here, as you can see that with Plotly, we can read about each data frame. For example, here we can see that, for example, the ocean proximity near bay, median income 3.96, median house value $280,000 for this specific data point. We can also, for example, zoom in our data frame. Here, as you can see, we can zoom and find each data point easier. Okay, this is the difference between Plotly and, for example, box plot or pay plot, or for example geographic dimension or scatter plot. Here we can't see each point data, but with Plotly we can simply read our data. And the last thing is to you can also save our plot in your computer. For example, you want to show this to your stakeholder or your client. They are not technical, they just can understand the chart, so you can save this chart and later show it to your client. It's simply the data frame you want to plot or download it, then plt.savefig. We name it, for example, house value distribution.png, and some settings. Then we run this, and also we plot it. Here we plot histogram. So this image is now saved into my machine in Google Colab by clicking this, and here, as you can see, house value distribution. You can download it, and here you can open your chart, and here, as you can see, your chart have been downloaded, and you can use this in your research, in your meetings to your stakeholders. Thank you guys, I hope you like this video. There is endless things you can do with your data frame. There is endless settings to your charts, many more different types of plots, which they require another video. You can also check the GitHub repository and read this on my website. I put all the links in the description. Thank you. Please like this video, subscribe to my channel, and tell me your idea. Thank you. Bye for now.